Swayam Prabha. Digital India. Educated India.
Good morning. Welcome to the ongoing online course on Engineering or Architectural Graphics Part 2, and in this course we are learning how to draw isometric drawings so far. So, in the last 2 weeks, as I said, we have already seen how to draw isometric projections of all different types of 2D and 3D objects. And in the last lecture, the first lecture of this week, we have seen how to draw combinations of solids, but most of the examples which we took were of rectilinear objects where we had straight lines and then they were inclining and they were connecting, combining together. That is what we have seen. Now, in today's lecture, what we are going to see is what if circular cylinders or circular cones are intersecting with each other, which is what we have seen in orthographic projections also. So, this is what we are going to see today through examples. So, I am taking examples and then I am explaining the theory. The basics remain the same for isometric projections. We know how to draw circles, we know how to draw reference planes. What I am doing here is taking the same theory and explaining it with the help of these examples, so that it is easier for you to pick up. Now, let us take this first example. This is the orthographic projections, orthographic drawing of the given combination of solid. Now, if you see this, what we have basically is we have two square based prisms. One is perpendicular, it is standing on the ground, it is perpendicular, and the other one is parallel to both the planes. The axis of this solid is parallel to both the planes, vertical and horizontal plane, and it is passing through the prism, square based prism, which is standing. So, now what we have to do, we can start from anywhere, but we have to remember where the reference planes are. So, I will tell you how do you draw this. Forget about this one which is parallel to both the planes, this solid, okay, forget about that. Let us just see that what is it if only this first one, the vertical prism, is drawn. So, what we have here is we have a square which is inclined. So, what we will probably need to do is we will have to enclose it in a square and then draw. So, what I am doing here is enclosing it in a square, so that we arrive at the square, take the height, whatever the height is given, and this is what we are going to see when we are seeing it here like this. Okay. Now, with reference to this, okay, now if I have to see this, this is where this particular base is and this is the bottom where this base is, right. So, this is where this base is. So, we have drawn two bases here and here, and then in between there is a certain height. Now, where do we actually get this diamond, this inclined square? Now, before we do that, what we know is where this point M2, which is here, and M4 is. Okay. So, what we can actually do is we can first draw M2. So, whatever this distance is, we can take the exact distance here, and whatever this distance is, we can take this distance here, and we can locate these 2 points M2 and M4. Now, M2 and M4, if you look at it, so look at it from the side here and assume that there is a plane which is passing through this. which is here, okay. And on this plane M2 and M4 are there, right. And if I were to draw a plane, which is what we have seen here, if you were to draw it here, and we take it up like this, this is the plane that we get, this is the plane, this is your point M2 and this is your point M4. Now, we have to arrive at this point, say M1 and M3, okay. So, if I have this and we already know M2 and M4, we can actually arrive at M1 and M3 if we know this height. So, what I am going to do here is take this height somewhere, say around here, this is where we are going to get this M1, this is your M2, this is your M3 and this is your M4. And if we join this, this is what we are going to get at this plane, right. But what we have is, it is going back, okay. So, what we can exactly do is, if we have on this top one, we can actually see this line where this M3 and M1 are coming. So, which is actually going to pass approximately like this, right. We can take this down, this is where your M3 and this is where your M1 is going to be. So, what we will actually have is a very skewed looking object here, and then we have another plane which is exactly parallel. So, we have this and the original M1, we can bring it forward because these are all parallel lines, and we can draw the inclined square in front, but the ones at the back, so they have changed. So, instead of this, it is now going back to this. So, this is what we are going to see in the bottom. So, this is what you will have, this remains intact. So, this stops here, this edge remains intact, which is what we are seeing here, this is getting cut almost here, right. This goes at the back, the top remains. Exactly the same thing we can do at the back. So, we can arrive at the point, say N2, we could take it like straight here down N2, similarly the N4 at the back of this. So, we can again draw a line and this goes down, we can actually have say N3 and same way we can have N1, and we can also take it because this is parallel, we could derive it like this, or we can make another plane face here which will give us this and this, and we can just join it. So, say we are arriving at this one here, approximately this one here, and in the bottom so 2, this is where 4 is going to come. So, this is what we will see, and this will be something like this. So, it is not becoming very clear, but what we can see if I just darken the so this is M3, so this is straight, vertical, and all this rest of it is behind this. So, if you look at this particular picture, this particular isometric projection, you can actually make a sense of this. Now, one problem why this isometric is not giving us very clear idea is because this is inclined, it is at 45 degrees to the VP, and that is why what we see here is almost a parallel face, a front face, because we are seeing it at a certain angle. However, if it was a straight solid a square base prism and then the another one was intersecting, we would have seen a much better picture, but this is how we will arrive at that. Let us see another example and see how we can arrive at that. Now, here this is two cylinders intersecting, and very clearly what we have to do is identify the reference planes and then start drawing it. Okay. So, what I am going to do is identify the reference plane. Now, one reference plane is this. Okay. This is one reference plane and this is another reference plane, which is what we are going to see. The reference plane here is this. Okay. So, there is a rectangle and within that there will be a square, and similarly on the other side we will have a rectangle and a square in this if we were also having a side view. So, what I am going to do is start drawing this one. Okay. So, what we have is we have say we have a rectangle and within this we have a square which contains this circle. Okay. Exactly same as this we have another one and we have a square which contains the circle. Okay. The circle here. Now, we can for reference we can draw, not just for reference, it will be what it will be seen here. So, we can draw these circles and we also have the circles coming here. So, this circle is this one and this circle is this circle. Now, how do we draw where these are going to meet? Okay. Now, if you divide the circle into 12 equal parts, which is how originally we were arriving at. So, we have these 12 parts, you can identify where these points exactly are and similarly here. Okay. So, let us have these 12 parts. All right. Now, what is happening is here we are going to be looking at how these ones are meeting up and where. So, if you look at this top one which is 10 and 10 and which is 4 seen here, which is actually on the top 10. So, if this one, so we know what is the distance of this, we know what is the distance of this, and this both of these are at the top. So, we know the height of them and we know the distances of them. So, we see that they are meeting somewhere here. Same thing we can do for this point 1, so which is here. Okay. So, it goes to the back and this one which further goes to the back and it meets there. Okay. Now, if I were to do it, this is what we will see. So, if you look at this, this is going to be an ellipse, but since these two are absolutely the same sized pipes, what we will see that all these points when they go and meet, when you are drawing them, you will see that they will all meet up in a line here. And if we were to take this, this is going to be at the back meeting somewhere here and then it is going. So, what we will actually have is we will have a line which is actually the ellipse when seen absolutely perpendicular. Okay. And what we are going to do is this, from where beyond it we cannot see the cylinders, and similarly this from beyond which we cannot see the cylinders both the sides, and this line which is the line which is joining these. So, it is slightly going back and these two circles. This is what we are going to see. I hope it makes sense. So, what we have seen here is these two circles So, it appeared very simple because we had the reference planes properly taken. So, we know this reference plane, this was the reference plane. I am just marking the endpoints of the reference planes for squares here, for squares here. And once we put them together, it was very easy for us to arrive at the intersection of the circle in isometric projection, and it will be the line. We can draw these thin lines, we can retain them, but this is exactly what we are going to be seeing if two cylinders of exactly the same size, same radius are going to intersect like this perpendicular. Okay. Let us see another example. So, you will know how we drew the 12 points and how we took the distances. So, now what this case has? It has one cylinder which is perpendicular to the HP, and there is another one which is passing through it, and its axis is parallel to both HP and VP. So, let us take this one. So, what I am doing is you can start taking by reference squares or rectangles. So, what I have done here is this is the reference that I am taking. So, okay. So, the top one I draw a circle. This is what you get. This is the top one. Okay. Now, in this one, for the same, if I extend this square, I get an extended reference. Okay. This is where this horizontal pipe is going to come. Okay. Now, if you look at this here, if I have to draw this, I extend, and this is the reference which I am taking. Okay. So, I make this reference. I am not making the height of this one, this is the reference. Okay. Now, in this one we have to identify where the square containing this circle is going to come. Okay. And this circle we are going to divide it into 12 equal parts. So, we will identify where this square is going to come, which contains this circle as we talk, and then we mark the circle and we mark the points, all the points on this one, say 12 points. We have divided it in 12 parts, we get these 12 points. Okay. This is what we are seeing from the side. Now, how much is the distance and where this is going to come, where it intersects this cylinder, this vertical cylinder, is what we will ascertain now. Now, look at this, this is 1 and this is 7. Okay. Now, 1, this is where it, I think there is a slight, yeah, okay. So, 1 is this, so this is where this P1 is going to come. Now, if I draw this P1 and I just measure the same distance, this is the point which I get. Okay. Look at this 4 and look at this 4. Okay. I take this 4 and I draw this. This is your P4. Same we do with 7 and we take it inside. This is where your 7 is going to come, and similarly we will get for all these. Okay. For all these points I am drawing thinly, and we get all these points. You do not need to do it at the back, but then wherever these points are coming, and then we join them. So, it will come something like this. This is how it will join, and this is not a straight plane. You can see in the elevation that it is slightly curving, and on this one this is what it is. For the rest of the cylinder, we will, the back, if you look at this here, this is a straight edge. So, we just draw this straight edge here from wherever we can see, and we can draw the same at the bottom. We will have this square, so we draw another circle at the bottom. Okay. this is in the bottom. Exactly the same thing we will do at the back. So, what we have is, again we have this reference, we draw this reference circle. So, we have this reference square at the back, we draw the reference circle, okay, divide it into 12 parts. However, not much of it will be seen, so we will only draw it for the visible portion, and then we start taking the distances here, okay, whatever those distances are. And then what you can see is that there is a straight edge which is going to be connecting, and all we will see is some portion of this rear one. This is what we will see when a smaller cylinder is going to intersect a vertical cylinder which is kept like this. So, it is actually passing through and through. This will be uninterrupted, and the circular part. If you wish, you can draw the rear one also. It is not coming perfect, but then once you draw it properly, this is how it is going to look like. I have not removed the green lines because you can actually see how the construction lines are going to lead us to this. So, what we are doing is we are only measuring the distances and keeping the axis parallel. That is what we are taking advantage of. So, this line is parallel to both HP and VP. So, we are going to be measuring this, which is parallel to both HP and VP. This is again parallel to HP and VP. This is perpendicular to HP. This axis is going to be perpendicular to HP, which is what we are going to identify from here. This plane parallel. So, all the lines are actually being derived, all the lines which we are drawing here, the points which we are drawing here is being derived from the orthographic projections which we have already got. So, the parallel lines remain parallel, the perpendicular lines will appear in connection with the other one, the non-isometric lines. So, that is what we have done here, and we have arrived at this example. Let me take one more example, which is cone. The process remains exactly the same, and we will get a little skewed drawing in the isometric, because we cannot exactly arrive at these points if we do not take these distances. The basics remain the same, the reference plane has to remain the same. So, let us take this, start by drawing this cone just as we did. So, what we did, I am drawing the cone first. This is the base of the cone, this is the axis, this is the apex. This is the base of the cone, and this is what we would see if this cone was complete. Now, what is happening is that this cone is being intersected by a cylinder, a circular cylinder, which is passing like this. Now, look at it in elevation, and we have to draw exactly the reference plane at the right place. So, if I look at it from the top, this is where my reference plane is, right. So, this is exactly what I am going to draw here. So, say this, it projects like this and to the back also. Okay. Now, if I look at it in elevation, this is where my reference plane is going to come, and this is, if I look at it in the side plane, this is what I see, and within this, this is the square which I am seeing within this rectangle. So, I say this is from the side that I am drawing this, and this is the square where this circle is going to come, right. So, we have identified where the circle is coming, and we draw this circle, and we have the reference. So, we have 1, 4, So, 1, 4, 7 and 10, and in between we have the other points also. Okay. So, this is how we have got. Now, we have this drawing in place, we have this circle in place, we have the cone in place. Now, what we have to do is look at it from the top and identify what these distances are. Okay. So, what we have is we have 1, 2, this is the point 1. So, 1 to D, okay, what they have taken is 1 to E. So, what we will do is we will measure how much this is and we will mark this point. This is parallel. So, we mark this point 4 and we mark this point 7, we mark this point, okay, if not 7, 5, I am drawing very thin lines. Okay. So, we will get all these points. We just have to draw exactly the same parallel lines. We will draw from here, this 1, 2, 3, 4 and like that, and see where they are exactly intersecting this cone. So, we will get all these points, we mark and we join. So, if you join this like this, in the bottom, and exactly the same thing we will do the other side. So, we have the reference circle, so we will mark these points. So, the other points are being visible here. Now, beyond this, since it is smaller, beyond this we can see that from this side we can actually see this one intact. So, when you measure you will see that you will actually not be able to, or maybe you will be, but in most likely cases you will not be able to see where it is cutting unless it is going deeper than that. So, we will see say some part of it coming and you will know that these are the points exactly where we have to join. This is how it will be cutting the cone like this. And then, so what we are basically doing is we have identified these 12 points here, which are these, and we have now, so 12 points here on this one, 12 points on the back here. So, this is what we have drawn, and now we are taking the distances from this to the surface of the cone and just marking them in parallel lines. So, if you have understood how to draw the orthographic projection of any such drawing intersection of solids, you can very conveniently transfer it to the isometric projection. I will just darken it now, so that you can very clearly understand that how this intersection is happening. This is what you will actually see happening, but the premise is that your orthographic projection has been drawn correctly. If there is a fault in your orthographic projection, then it may, or rather it will be extremely difficult for you to draw the exact isometric of the cone. And we can actually have the ones at the back, the points where this cylinder is intersecting this cone, and this is what you can actually get. So, maybe you will get something like this here. This is what we will get if this cylinder is intersecting a circular cone. A circular cylinder is intersecting a circular cone simply by following the same process. If you can't understand anything, all you have to do is identify where is the x, y and z. You can also take the reference line. So, I stopped drawing the reference line, earlier I was drawing regularly. So, if this was the reference line, this is your VP, okay, and this is your HP where the cone is kept. So, now probably you will be able to make a better sense of it. So, all we are doing is in x, y and z, we are locating these points. So, if I have to take this, so I know what is the distance from say x y, and so I know in the base this is where it is, and above it z, I measure the height and I take this. So, I will only measure from the orthographic and transfer it onto the isometric, and I will be able to, and then of course, you have to understand how the solid looks like, and then when you join you will be able to arrive at the isometric projection. So, this is one exercise which you can try at home, you can try doing. All I will understand is you are drawing these reference planes. So, these are the reference planes which we are talking about, two reference planes here, one reference plane on the top and another one at the bottom. Now, this reference plane at the top that we are talking about covers this entire thing. Okay. So, you can get these points, and then within this we can actually have a square cutting here. So, we can identify these points on the top, we can identify these points in the bottom, okay. And then on these two reference planes we can have, so this is the reference plane, on this we can have a smaller square reference plane which will contain this circle and the same circle at the back. And then once you have all the reference planes in position, then we will start drawing where each of these lines is going to cut. So, what is the length of each of this line, and just draw it on this. I hope you will be able to arrive at the correct solution. In case you are not able to do that, please write back to us, we can help you arrive at this, but just remember the basics of isometric projection, and I am sure you will be able to arrive at that. So, thank you very much for joining me today. I am closing my lecture here. See you again in the next lecture tomorrow. Bye bye and have a good day.